MCQ 27 is with regards to the blast furnace. Alright, I will use this chance to do a little bit of a side diversion. It's very important to know what are the reactions that happens in blast furnace. So the first part here will actually involve the production of carbon dioxide. And that comes on two-way, coke plus oxygen to form CO2. And the limestone of calcium carbonate will thermally decompose to form calcium oxide plus carbon dioxide. The second part of the process here is the production of carbon monoxide. And this is using the CO2 from the first step to react with more coke to actually give us CO. And this is balanced with a 2 that's in front. The third step, which is the main step here, is the reduction of hematite. And hematite is given the formula of Fe2O3. It's actually an iron 3 oxide. So Fe2O3 will be reduced by monoxide to give us iron, as well as carbon dioxide, balanced with a 2, 2, 3, 3. Important thing to note here is that the iron is molten because the temperature in the blast furnace is really high. It's way above the melting point of your iron. The last step here is going to be an impurity removal process. We're going to remove the sand that is found inside your hematite. So silicon dioxide here will react with the calcium oxide that came from the first event of the production of CO2, and this is a group 4 oxide, so it's considered to be as an acidic oxide, whereas calcium is considered to be a group 2 element, so this is considered to be basic oxide. So we are actually witnessing a neutralization reaction, and this will form calcium silicate, otherwise known as our slag. Again, it's going to be molten because the temperature is way above that of the melting point of slag. So that's diversion, but coming back to the question, we're looking for reactions that are legitimately redox. So we have always encouraged everyone to use SHOE. Right? So as mentioned in the previous question, I would have a general inclination to use oxidation state to talk about oxidation and reduction. Now, so long that we can prove that one of the items have the oxidation state increasing or decreasing is good enough to say that a redox reaction is actually happening. So for the first case here, I'm just going to go towards iron comparison in my iron 3 and my elemental iron. So iron 3 will have a blast 3. And this is 0. A reduction has already happened here, so I will say that number 1, there's a redox that's actually happening. For number 2, you can go with either, but I'm just going to go with elemental oxygen and the oxygen that's found within carbon dioxide. This is a 0 and this is a -2, so a reduction has happened for oxygen. And finally, for the last one here, this is your calcium carbonate. This is your thermal decomposition reaction. So calcium here has an oxidation state of +2, so calcium doesn't really have any change at all. Oxygen holds a -2, -2, and -2. There also really isn't any change. So again, let's calculate the calcium oxidation state in this case here. So calcium has already been given a +2. We want to calculate carbon, right? So plus carbon, which is 1, just going to let it be X. And we have a total of 3 oxygen. So plus 3 times -2, this will be equals to 0 because there isn't any charge for calcium carbonate. So X will be -2 plus 6 to give us an oxidation state of +4. So similarly over here, to calculate the oxidation state of carbon, we have 1 carbon and 2 oxygen. So X plus 2 times -2 is equals to 0. There's no charge. X is equals to +4. You can see that for calcium, it did not change. Carbon, it is not changing because it's +4 at the start and +4 at the end, and oxygen remains to be as -2. So number 3, since there's no change in oxidation state, this is not a redox reaction. So B will be the answer for this question.